Welcome back. This is the part two of chapter two for CIS 1. And just a real short wrap up here, talk a little bit about storage devices. And I kind of want to talk about the different types, specifically magnetic storage devices, optical storage devices, that's our CDs, DVD-ROMs, and then the most exciting today, SSD or solid state storage devices. So basically, our storage devices, that's our secondary storage. We talked about RAM is our primary storage. We talked about the CPU, and now we're talking about secondary storage. And as I mentioned a little bit earlier in part one, our data and instructions live somewhat permanently on our secondary storage, our hard disk drives, or CDs, or DVDs, or Blu-rays. And then they're transferred from secondary storage to primary storage, and then primary storage to the CPU. And as I mentioned with primary storage, it's volatile, which means when and that's what we're talking about RAM there, and when the computer is off, or if you get a little glitch, anything in RAM disappears. So it's real important as we create documents, or we create programming code, or we edit pictures, or what have you, that we make sure that we save, and when we save, it's going to go from RAM into secondary storage and then when the computer's off, the information in secondary storage stays there on a semi-permanent basis until we decide it needs to move on. So that's real important to realize, that it has to go to RAM to be processed, and that RAM is temporary. It's what we call volatile. No electricity, no storage in RAM, and so we want to make sure it's on secondary storage. So just to emphasize that, that's why it's so important when you're working on, let's say, a spreadsheet or a Word document. Don't wait until you're all done to hit that save button. The whole time that you're working on it, until you hit that save button, it's in RAM. So if there is a problem with electricity at your house, if your computer has a little glitch and burps and restarts, your information that you're working on is gone. So I have a little mantra: save early, save often. As soon as you start working on a document, as soon as you do the first sentence of a paper, the first cell of a spreadsheet, the first pixels of a graphic, hit that save button, and now it's in secondary storage. And every time you pause, hit that save button again, and it will be updated, and the new information will be added to what's already there. And so then if you have some kind of electrical issue or computer malfunction, your information is still on secondary storage and should be retrievable. So the first type of secondary storage I want to talk about is magnetic storage. This is what today's hard disk drives use. And basically we have a surface. It's a hard disk of the platters. You can actually tap on them and you can hear them. And they are coated with an iron oxide, which can hold a magnetic charge. And so basically we have a read-write head, and this read-write head aligns these ferrous particles that are on this platter in a north-south, in a north direction or a south direction, to represent bits. Remember, everything in the computers is zeros and ones. So we're going to have very small magnetic dots on this hard disk drive that are zeros and ones. And so as this hard disk drive spins, and a typical hard disk drive spins at 7,200 revolutions per minute, this read-write head can pick up different the zeros and ones that are represented by this different orientation of these magnetic particles as it spins underneath that read-write head. So here's a typical hard disk drive. So here's the platter that I mentioned, and this one actually has two platters. So then it has a read-write head at the top platter, it has a read-write head for the bottom of the top platter, a read-write head for the top of the second platter, and then it may even have a read-write head for the bottom of the second platter, depending on the drive. And so then, as I mentioned, this thing spins at 7,200 revolutions per minute. And these read-write heads are moving back and forth on what we call these actuator arms. So actuator arm here are moving back and forth, reading those magnetic blips. So hard disk drives are probably one of the more common things to fail on your computer system, laptops, and desktop systems, and that is because they're actually mechanical. So if you're using this thing year after year, it's spinning 7,200 revolutions per minute, some of them as fast as 10,000, slower ones are 5,400 revolutions per minute. But the whole time that computer's on, this is spinning, spinning, spinning. So there's bearings that wear out. This head can have a little problem, and it can do what we call a head crash. That's what they're kind of mentioning here in this bullet on the slide, where the head actually touches the surface of the disc, and if it does, it's like a, it's gouging. It's taking a big gouge out of the disc, and you're going to lose some of those magnetic spots, which represents your data. Dust particles, anything else that gets in there. So hard disk drives themselves are usually vacuum sealed. They're not something you can open up. Usually, if you're viewing a hard disk drive in the fashion we are here in this slide, there's something wrong with it, and you've opened it up to kind of learn about the anatomy of a hard disk drive. You can't fix it and put them back together. So that is why, because they're fallible, you want to make sure that you have a backup. And it's really easy today to back up in the cloud. It's really easy, and we'll talk about backups in another topic. It's very easy to back up to thumb drives, flash drives that we'll talk about in just a minute. And so you don't want to just depend on the data that's on your hard drive, because they do break down. Not on a monthly basis, not on a yearly basis, but typically if you have a machine long enough, you're going to have a hard drive failure. So very, very common failure. Second type of storage, optical storage technology, and we're probably all familiar with these. We watch a lot of our movies on them until we started streaming. So compact discs, DVDs, Blu-rays, these are optical. So they're not, again, we represent zeros and ones, but not magnetically anymore. Now we use laser beams, and we use something called pits and lands. So this is a electron microscope view of the surface of a CD, and basically what the laser beam does on a CD, a compact disc, when we call about a CD-ROM, it's a compact disc read-only memory, and in that situation, the laser, these pits have been burned into the surface of the CD at the factory. And what happens is this laser beam, when it hits a land, the laser beam reflects back into an eye that is able to detect it, and it says, hey, that's a 0. And when it hits one of these pits, the laser beam's diffracted. It does not reflect back, and hence you have a 1. So that's what we're able to do, again, is represent those zeros and ones. And so the information on a CD is stored in a spiral. It starts in the middle, and it spirals out with all these different pits and lands. So these pits and lands are very small. In fact, this spiral on a CD, if you were to, can't write CD very well, if you were to stretch it out, it would be 3.7 miles, actually over 3.7 miles. So that's how tightly things are packed together. Then, of course, a DVD holds even more information, and if you could unwind the spiral of a DVD, they work in exactly the same fashion. It's almost 8 miles, 7.8 miles, the spiral on a DVD. So quite a bit of information are packed into that. 3 different categories of this optical storage: the read-only that we mentioned a moment before, recordable, and read-writable. And these are the same whether it's a CD or a DVD. So your CD-ROMs, those are your old music CDs, a lot of, and DVD-ROMs. Read-only memory, and that means that the information's burned in at the factory, so it looks like it does here on this slide. So we can't repair these; that's permanent. But there are times we want to record them. So when you record a music CD, for example, or you want to record a video on a DVD, you're going to use recordable versus rewritable. You're going to use recordable, and recordable actually uses a die, and then the laser beam itself is going to go through the different layers, and it's going to hit this dyed layer, and at this dyed layer it's going to basically change the opacity of the surface, so it won't let light reflect. And so basically we're able to put our zeros and ones by heating up that dye and kind of, if you will, making a dark spot that's no longer going to let light through. It's going to make that dark spot and create a 0 or 1. Once we change the characteristics of that die on a CDR or DVD-R. We can't change it back, but it works really well for the permanency if you're recording music or videos. Now the RW uses a phase change technology, and that same idea, we're going to have the laser beams going to hit a specially coated surface, and if we heat it to a certain temperature, we're able to change the orientation or change the opacity of a particular spot, and if we heat it again, we can change it back to what it was. So read-writable allows us to use the CD or DVD over and over again, but that doesn't, so that's great for data, so the paper's for a class, for backing things up, but it doesn't work well for video and music. And then the last bit of secondary storage technology that I want to talk about is solid state storage. And so probably solid state storage, the ones we're all used to, are these thumb drives, or what we call flash drives, thumb drives, USB drives, because they use a USB interface to plug into the computer. Very, very popular and common and robust type of storage. So what we're starting to get now is we're starting to get what we call SSDs, solid state drives, and they're more expensive, but they're faster and they're much more robust. There's no spinning platter. It's simply circuitry that is turned on and turned off using electrons to represent our zeros and ones. So kind of your medium to high-end laptops have solid state drives. It typically would have a 128 megabyte drive. Solid state drives are more expensive than your traditional magnetic drive. You can get a 1 terabyte, 1 trillion byte magnetic hard drive for, $70, $80, where a solid state drive that's say 120 gigabytes, a tenth of that, a tenth of the magnetic drive size is going to cost you $125. A half terabyte solid state drive is going to be over $350 versus $70 or $80. So they will come down in price, just like flat screen monitors did a few years ago, and the capacity will grow larger and larger as different factories ramp up and start producing them. But they are pretty cool. So a lot of times what happens on systems these days, where people will get a smaller solid state drive, say 120 gigabytes or something, to put their Windows operating systems on and maybe load some of their applications on, because they're very, very fast. And then they'll put their data on a magnetic drive because the data doesn't have to load quite as quickly. So look for solid state drives. And again, that's what your thumb drive is, but they're actually in your smartphones are using solid state storage, iPods, solid state storage. All those type, I shouldn't say iPhones, mobile phones, your cell phones, your smartphones are using that solid state technology. Then the last thing I want to talk about is surge protection and battery backup. So basically this is the part of the chapter that kind of talked about protecting your computer and then protecting it from theft, but also protecting it from electrical issues. And power surges, and this is such an important topic because power surges are very common here in Humboldt County, especially in the wintertime. We get those big storms, those big south winds, and power lines are knocked out, or we just get fluxes, and it just doesn't take much. And a power surge is just a really brief increase in electricity through the wiring in your home. Envision having a hose, and you kink the hose, and when you unkink the hose for a moment, it really surges and then settles down into the normal water flow. Same thing happens with electricity. If we have a lightning strike, or if your power goes out, when the power typically comes back on, there's a brief surge, and that surge typically is transported through your power lines, and if it goes into your computer, it's just going to burn out your computer. Your computer uses very low voltage. It's very, very sensitive to electricity, so it doesn't take much to completely make it unusable. And so a little power surge would do that. So one of the things you want to do is you want to get a surge protector at minimum. APC is a brand I love. This is an exact model that I have at home. Belkin is another good brand. You're going to get what you pay for. So if it's $5, you're going to get about $5 worth of protection. And usually what I use is a good layman's barometer for how good the surge protection is they usually warranty your hardware. So it'll say, this surge protector, we warranty $500 worth of your hardware. So if something happens to it, they'll replace $500 worth of your hardware, or $1,000 or $1,500. So kind of look for that type of hardware warranty on the surge protection. And again, you can't go wrong with an APC. And so then your what we call your battery backup or UPS